Hello everyone. My name is Priyal Himanshu Kapadia and my student ID is S224741685 and welcome to my tutorial on QUIC um, which stands for Quick UDP Internet Connections. This is the tutorial from part SIT 202 Computers, Networks and Communication. And in today's session, I'll be explaining what QUIC is, why it is developed, its features, advantages, applications, and security considerations. We'll also look at the practical demonstration of QUIC in the Wireshark using Wireshark. So let's get started. Basically, what is QUIC? So QUIC is nothing but just a transport layer protocol that was originally developed by Google in 2012 and then later standardized by IETF as RFC 9000 in 2021, and it is built on top of UDP but provides many features we usually associate with TCP, such as reliability, congestion control, and it also integrates TLS encryption directly into the protocol. In short, QUIC is designed to make internet communication faster and more secure. Then the second thing is, why do we need QUIC? QUIC is Q the traditional stack of TCP plus the TLS plus the HTTP2 has a few problems. The first is like establishing a connection often takes one or two round trips, which increases latency. And second, that TCP suffers from head of line blocking, meaning one delayed packet can block the entire connection. And then, wait, where did the Okay. Yep, entire connection. And finally, TCP connections struggle when a user switches networks. For example, moving from Wi-Fi to mobile data. So this all problems are addressed by QUIC by combining transportation, encryption, multiplexing into a single protocol with faster handshakes and support for zero round trip connections. Then let's talk about QUIC functionalities. Some of the key functionalities of QUIC includes multiplex streams, which allow multiple request and response to happen independently without depending or blocking each other, we can say. It is it always and it always um encry- it is always encrypted using TLS 1.3, which improves security. QIC also supports connection migration. If one can what how do I if one changes the IP address or maybe switch the networks, the connection can still continue, like there will be no breakage. Also, it supports faster handshakes, often requiring just one round trip and even zero round trip if a session is resumed. Finally, it is built in congestion control and reliability mechanisms, making it very much reliable for modern internet use. This was the functionality. Let's talk about frame format. So the frame format is QUIC uses different frames formats to manage communications. The stream frame carries application data, and the ACK acknowledge frame receives packets, and then the crypto frame is used during the TLS handshake processes, and the ping frame helps the connection keep the connection alive, we can say. Each frame has a specific type field that allows different protocols to efficiently handle different kinds of traffic. Now let's talk about advantages and disadvantages. So the few advantages of QUIC are: it reduces latency, it has multiplex streams, stronger security, and better for mobile clients. And the disadvantages are like when it the CPU overhead. It is like always encrypted, so it gets a little difficult, and then harder for middle boxes or firewalls to inspect traffic, which can cause deployment challenges. And also, because it's newer, it's not as mature as like the optimized TCP. in every, so like it is not as optimized as TCP in every situation. Now let's get to applications using QUIC. QUIC like is already being used in many popular applications such as Google deploys it across search, YouTube, and Gmail. Also, Facebook and Instagram has also used QUIC for faster content delivery. CDN provides like Cloudflare and Akamai support QUIC, making websites load faster. Yep. And video conferencing apps like Zoom and Microsoft relies on QUIC to improve the performance. And importantly, QUIC is the foundation of HTTPS, which is becoming the next major version of web protocol. Now, let's talk about security and threats. From a security perspective, QUIC is encrypted by default, so it prevents eavesdropping or, tampering. There are still some threats which are like amplification attacks, replay attacks, traffic analysis risk. So yeah, there are still a few threats. Like even though QUIC is encrypted, but metadata like the packet size and timing can still be observed, which allows like some traffic analysis. Overall, though QUIC is considered more secure than traditional TCP connection, but it is like more secure than TCP connection is what I want to state. Now let's talk about the scalability. One of the QUIC's strongest point is scalability. It was designed for global large-scale internet applications. Then its connection migration features like it makes it like ideal for mobile users who often switch between like networks from like Wi-Fi to internet or something. It also performs well in high latency and like lossy environments such as satellite or rural internet. This is why major internet companies have like I have been like quick to adopt the QUIC as like part of their infrastructure. Now, as the video I have now I will show you the demo of like demo of the Wireshark demo where we will analyze the handshakes and initial packets. So what we are gonna do is we are gonna clear the cache history of my Chrome because it will help us give like fresh requests. It will help us understand it, like give the fresh requests. And yep, I have opened the Wireshark as well. What we are gonna do is while the Wireshark loads the request, I'm gonna start with youtube.com on my Chrome, and once it starts, I'm gonna run a video. I'm gonna like run a random video. And
one of you can create your own website by saying
yep, and then refresh it so that we have got like good amount of
what have you
data.
told you that
Yep.
confidence.
Okay, now I'm gonna do is stop the capture. And we are going to apply the filter QUIC after stopping the capture. I'm going to do is apply the QUIC filter and in Wireshark so that we can isolate the QUIC traffic. As we know that QUIC uses UDP instead of TCP, so traditional TLS filters would not capture. Now what we are gonna do is identify the QUIC, identify the packet types. So what we see over here is the like first the initial ones. So initial is nothing but it starts the connection, similar to the TLS client hello. And then what we see is we have got ORTT packets, which sends like the early data immediately if a sessions is resumed. And then what we see is we have got handshakes after that. The handshake packet represents that that the server has responded. And then finally we have got protected, which is one RTT packet which actually carries the encrypted video or page data. Now what we now this is like the QUIC stream. Like first it is initialized, and then 0 RTT, and then handshake, and then 1 RTT. Um, Now what we are gonna do is, like, we are gonna open this page and inspect it, and then open our dev tools, go to network, and then I have already enabled the protocol. I have enabled the protocol, and as we see that this shows H3. Like, in it is showing that it runs over QUIC, because uh H3 runs on QUIC. This is what I wanted to say. Now, what I'm gonna do is explain what are like practical takeaways from this demonstration. So what I did in this practical demonstration was, we saw that QUIC, it was in action, encrypted and fast and efficient data transfer. It improves connections setup, it reduces the latency, and then it supports multiple streams without actually blocking. And it is like the foundation of HTTP 3. We observe the packets in Wireshark as well, which confirms the like theory which I studied, which I researched and understood. And this was my task, like to explain and show a quick tutorial of QUIC. To conclude, only thing I would like to say is like, this was the practical implementation, and it shows all what I have thoroughly studied through theory. That's all. This was my task. Thank you so much. I'm open to questions, and thank you.